Alright, is it videoing now?
Yeah,
Alright, okay. Is it like what half of the board does it get?
Oh, that.
Whole board?
No,
The
that
whole
right
board?
there.
It's at the line.
Like here?
Right
Yeah.
there.
Perfect.
Yup.
Yeah.
Is it
Alright.
recording?
Alright, everybody say hi to Sarah.
Hi, Sarah.
Hi, Sarah.
Hi, Sarah.
Alright, have a
Bring me cheese from Wisconsin.
oh my soul. Alright. So we're gonna talk about similarity. Similarity talks about things that they have in common, alright? So let me ask you this question. When we talk about transformations, the first four we talked about was a reflection, a translation, a rotation, and an identity transformation, right? Talked about those four things. Now, what were those? Those did not change anything to do. They did not change anything, all right, when it came to the actual size and shape of the whatever figure that you were moving. The fifth one was dilation. What was a dilation? Let's review that.
Shrunk and bigger.
Okay, bigger or smaller. Now,
Or smaller.
when we talk about similar, that's more like what we're going to be talking about today. So what we're going to talk about, and we're going to go back to the one thing which we need to know, which is what is a scale factor. So we have dilation, we get a scale factor. What is a scale factor? Some of you did not know how to define this on the test. Let's make sure you know how to define it now. Okay, so what is a scale factor?
How much it is increased or decreased?
So
by.
the increased value or the decreased value. Now, how would I solve that? Image
Premature.
over pre-image. Okay? Image over what the pre-image is. Okay, so remember if the pre-image is this little one and it's 4 and the big one is 8, we would go 8 over 4, which is scale factor of 2. Okay? So is everybody following that?
Yes.
So let me ask you a question. Are these two similar shapes?
Yes.
Yeah, they're similar. What's the difference in those two?
The size.
The size. Okay? Now, when you think about it, when you start thinking about similar shapes and similar figures and similar things, what you will understand is this. This shape, would you agree with me that if I have would these two be? No, why not?
Because
One's
it's
a
not that
triangle,
big.
one's not.
Because it's not even close, right? It's not even close. Even if the shape has similar characteristics or a little bit of characteristic, it's not going to work. So what you have to understand is when it changes the form, the shape or the shape or the angle and those kind of things, it is not going to be working as a similar figure. So what we're doing today is simply getting in the idea of working proportions and working similar. Similarity gives us proportions, okay? So if you look at the first thing, what we're going to be talking about is how would you find proportions? So how would you find proportions? Does anybody know what a proportion is?
It's like a certain part.
Excuse me?
I said certain part of it.
Certain part? Okay. So let's go back and think about it this way. How many of you ate lunch yesterday? How many eat lunch?
Yeah.
No.
Who ate lunch? Everybody ate lunch?
No.
Okay, so let me ask you a question. At lunch, okay, you have an 8-year-old and a 10-year-old and a 15-year-old.
Wait, I have children?
At lunch, at a lunch.
Oh, okay.
Can I ask you a
You
question?
know that already.
Okay, if you think about this way, who gets a bigger proportion or a bigger portion?
The 15-year-old.
Why? Because they are.
Bigger.
So you might give the 15-year-old 2 times more than the 8-year-old, essentially. You agree with me? Why? Because their ages is 2 years 2 times bigger, right? The goal is this. When you start talking about proportions, it's like a portion. How big this one is will determine how big this one over here is. So, but you're dealing with your scale factors. So you're using your scale factors to determine your proportions. Proportions are what is going to drive your similar triangles. Okay? So if you have, let's say that I have,
Bless you. What?
All right, so watch carefully. Let's look at this. Let's walk through this together. So, I know it might not be perfect, but let's just think about it together. What if these two triangles are similar? What are our proportions? 5 relates to what side over here? 1. So we go 5 over 1, right? And what's the other one?
10 over 2.
How would I solve to see that this is correct?
Would you just mark it to make sure that one's the other? Which one's the pre-image? Like, would you just
Doesn't-
mark it?
It doesn't matter which one's the pre-image, which one's the image. In this case, why?
Okay.
Because as long as if the ones on the bottom of the 2 has to be on the bottom.
Okay.
Because I'm comparing those two. All we're doing is comparing, just like the 8-year-old and the 15-year-old. I look at their plate and go, okay, that's a lot of cheesesteak for a 15-year-old. This is how much cheesesteak for an 8-year-old. That's the portions of what you're going to do. So when I cross multiply, 5 times 2 is
10.
10 times 1. So if that equals, then guess what?
Good stuff.
They're proportionate, right?
Okay.
Does everybody agree with me?
Yeah.
Okay, is everybody following me?
Yeah.
Everybody understand what we're doing? So now, let me get this to move a little bit. So if I have, and what we're going to do is, we're going to do some without some shapes to help us get started here. So x over 9 equals, let's see, actually let's do this one, sorry. X over 5 equals 9 over 15.
So we're not
Alright.
starting a next chapter?
This is the next chapter.
No, it isn't.
This is going right into it. Now watch.
World.
So how would I solve for that x?
You cross multiply.
Cross multiply. X times 15, right? So 15
15.
x
Yeah.
equals 5 times 9.
49.
49?
45.
Good.
Sorry, I just added a 4 for some reason.
So what do I do next? If 15 is, divide both sides by 15, x equals,
3.
okay? So there's your math. Now, so I don't want to confuse you, but everybody watch. Here's how I would have solved this problem. Okay? I would have canceled top and bottom. 3 goes into 9, how many times?
3 times.
3 goes into 15, how many times?
5.
X over 5, 3 over 5. What's my answer? What does x equal? So you can do that if you choose to. It's not wrong. I'm not saying you have to do it that way. I don't want to confuse you, but I want to give you another way, an alternative way to solve. Okay, so let's look at the next one. 2 over y equals 3.5 over 4. Or 14, sorry, 14. Sorry. All right, so let's solve this. What do we do?
Either cross multiply or.
If you can cancel top and bottom,
Yeah.
I always suggest doing that.
Okay.
That's my suggestion. You don't have to. Okay? Can you cancel top and bottom?
No. Yes, you can. It'd
I
be
mean,
5 over 2
same thing.
because of 7.
All right, listen. 3.5 is half a 7.
Oh.
Yes?
Oh, I thought that was 35.
3.5 is half a 7. So, if I reduce that, think about that. That times 2 is 7, right?
And then comes 4.
So, it's going to be 1 over 4, right?
Yes.
Does that make sense?
Yeah.
You can do that. You don't have to. That's how I would have done it. There's no right or wrong answer and no right or wrong way. It's just the way I do it. Okay? Yes.
Can you cross with it?
So now, we're going to cross multiply. This is the way they teach you. There's 2 different ways to do it. That's why I'm going to go both ways, show you both ways. One way, straight cross multiplication. 2 times 14 is 28 equals 3.5x. Now what do? 3.5, 3.5. What do we get? 8. Okay, so now my way. Okay, just a second. My way, the way we were going to do it. 2 over y equals, I'm going to reduce, I'm canceling like this, and that gives me 1/4. Y equals 8. Okay? Both got the same answer except for I used x. Sorry. Okay? Both got the same answer. Which one was easier? I think, well, here's the reason. I don't use a calculator. I'm a non-calculator person. Okay? I don't like calculators. I'm anti-calculators in my own life.
What they do.
Just because I'm anti them, I don't anti them in the rest of everybody else's life. Okay? All right. I just choose to not use one. It's a choice, personal preference. All right. Yes.
Are you able to reduce 2 and 14 like from across from each other?
No. Okay. So what? And he gets a good question. The reason is because you're going across an equal sign.
Doesn't equal if you cancel.
Okay. No. Because see, if this was 2y times 3.5 over 14, now yes. But this is not times, it's equals. It's across, it's two separate equations. Does that make sense? And that's and this, by the way, guys, she just asked a question that most of you will probably get wrong because that's what you're going to do. You can't do that. When you go across the equal sign, the two separate equations, you cannot cancel. It's like this. Here's how I remember it. When you put an equal sign in there, what does it do?
It equals it. Nice job.
Makes it two different.
It separates the two equations. So in other words, Katie, Joel, they're separate entities. Now, Joel can eliminate on his side. Okay, remember, he can eliminate on his side. Katie can eliminate on his side, but when they compare, they have to they multiply the two things times each other. Okay, he can't touch hers to eliminate. Okay, does that make sense? And vice versa. It doesn't work. If I had Skittles here and they both had piles of Skittles, they couldn't do that. Now, they could eliminate once they multiply to solve who has less or more. Okay, and the proportion thereof. But on her side of the equation, she gets to manipulate them. On his side of the equation, he gets to manipulate them. Does that make sense? But you can't cross it. Okay? You cross it in order to solve for who doesn't have the proportion. All right? Any questions on that? So let's do another one. Let's practice another one. All right, is everybody following? Are we good?
Yeah.
All right, let's do another one. Give you a chance to make sure you get this. This is, because by the way, the whole chapter, listen, the whole chapter stems on this simple math technique. All right? The rest of the chapter is going to come down on this. All right, here we go. So, A over 4 equals... Okay? All right, so let's solve. What are you going to do? First step, what do you want to do?
I would like to.
Brenton. I pointed at Brenton.
I'm sorry.
Sure it's not Caleb.
Nope, I'm sure it's Brenton. I was pretty sure I pointed at Brenton.
I think I changed my name yesterday as Caleb.
Go ahead, Brenton. Tell us what you want to do.
Cross both of them out, divide by something.
All right. So cross it. Which one are you going to cross out?
The top
Yeah.
one.
These two like this.
Sorry, I'm sorry.
Yes.
Okay. So, all right. A times 49 equals 4 times 128, right? Or 28.
Right.
Now, listen.
That's a big number.
Listen. We know this number. Now, think about this. Everybody, look. Is A bigger or smaller than 4?
Smaller.
Smaller, because 28 is smaller than 49.
Yep.
So you know that's what you're looking for, okay? So 49, A equals 4 times 28, which is,
112.
what is it?
112.
88.
Divided by 49.
I think it's 4.
A equals what?
40. A equals.
Do that math. in your head real fast.
2.285.
2.2.
Just added it.
No, it's 92.
What?
2.92.
I got 40.
No.
So watch.
Okay.
A over 4. So watch carefully. 28 over 49. So here's how I would do it because I'm going to get mine in a fraction quick. 7 goes into both of these, 4 over 7. So it's 7a equals 16. Divide by 7, divide by 7. A equals 16 over 7. Which, by the way, is that right there.
Where's it?
Alrighty.
Okay? But there's how you would solve. This is the easy way to solve it.
Easy way.
In my opinion, because now I don't have to use my calculator.
Alright.
Okay? I don't like using calculators. I think they're a crutch.
Demeaning.
No, they're a crutch. In other words, you use something that then you don't have to put weight on that particular part of your brain. And by the way, when I was your age, I used a calculator. What I did is when I went to college, my professor would challenge us to do this stuff in our head. And the only way you can do this stuff in your head is if you start eliminating stuff this way.
Wait.
Now, I was a math major, so there's a reason why. But that's what I did, and I had to force myself to do it in my head. It's very easy to do it based on paper. Like for instance, let me ask you a question: how many of you memorize phone numbers?
No.
No.
Okay.
Something.
Some.
Yeah.
911.
Back in the day, you didn't have a choice. You had to remember phone numbers because you didn't have a directory in your phone. Now that your phone has the directory in it, why memorize it, right? It's just easier. Like for instance, why memorize anything? I can just say Google, what is, and it tells me the answer. Right.
When we have
Yeah, that's the mentality, and that's what a crutch is. All right. Now, so let's think about this take us one step further now that you know how to do proportion. Any questions on how to do proportions? Are you guys good? Okay, so now let's think about this way. When I have similar triangles, so let's say I have a triangle, and I already showed you a little bit. Do the problem in the book just because I know it'll work out. I don't have to do the math in my head here.
Brady's not listening. Come on, Brady.
Is it still recording?
Yeah, it is.
Ow! Joel, why'd you hit me?
Because I did.
What? Because I did it?
All right. Let's do this.
25.
All right, so let's solve these for kicks and giggles. All right, first off, can you tell me? So these are look at the drawings, okay? So on the board you have two triangles. Now we will talk tomorrow on similar triangles. There's 3 ways to prove, like how remember we had 4 ways to prove triangles were congruent.
Yeah.
There's 3 ways to prove triangles are similar.
Wow.
We will cover those tomorrow. But for today, you need to understand how to develop that. So, I'm going to tell you that these are similar. How do we know they're similar?
Because if
Angle. Now, remember this theorem way back.
Yeah.
If 2 angles are congruent, the third one is.
Always congruent.
So you have to remember that because here's the reason. Your triangles have to have the same shape. So do they have the same shape?
Absolutely.
I know they're not drawn with the same shape, but they have marked that they're the same shape. Now, so, question. What's the scale factor from here to here? Can somebody tell me what the scale factor is?
Double.
It's a large. Let's say this is the pre-image. So what's the scale factor?
2.
It's going to be more than. It's going to be might be less than 2. It might be. How would I solve it?
The first row of 27.
So if the pre-image is 27, remember what's the fraction, guys?
New image over pre-image.
Image over pre-image.
Oh.
Pre-image. So 44 over
27.
Everybody got that?
That's what I'm saying.
Now, so if we reduce that, what did that reduce to? Does anybody know?
14 over.
Can it reduce?
No. Yes. No.
No,
you
it's
can't.
0.61.
I lied. No. You can't. I'm telling you no. Except for maybe 4.
Wait, hold on a second.
Whoa.
I made it. Hold on. Let me.
He made a.
I copied wrong. I'm not a good copier.
You done goofed.
All right, let's try this. That'll help.
You done
So
goofed,
now it's
Gary.
33. Sorry, 33. So
Okay.
can we reduce
That'd be
that?
11.
Yes. Yes, you can.
Four
Down.
over
4 over 3.
Right.
Alright.
So now, here's my question. How would I solve for y and x? How would I solve for y and x if I have one fraction here and I have these numbers here? How could I solve that? Elisa.
Take those numbers and multiply them.
Okay, so making our proportions, right?
Yeah.
So 4/3 equals what? So let's say 27. Let's choose 27. Which one does that correlate with? X or Y?
X.
So we're gonna put, where are we gonna put 27? On the bottom or the top?
The
Towards
top.
No.
All right, listen, hold on.
Alright, guys.
Where was 33?
On the bottom.
So where would 27 be?
On the bottom.
Because remember, Joel has to manipulate the ones on his side of the triangle.
And he cannot touch Katie's.
Okay, so this is gonna be 27, and what's gonna be above it? X. Cross multiplication. 3x equals what? 4 times 27 is?
It's something.
108.
It's around 8.
108.
Oh, what?
Divide by 3. X equals what, guys?
How do you guys not know this? It's 36.
Okay, so we get one
You have the
answer.
calculator open, Joel.
Calm down.
That's a
All right.
crutch.
It's a crutch. You're crutching along, Joel.
I don't see you guys answer a question.
Tiny Tim. All right, next one.
That's expensive.
So, how would I solve for y? Johan. All right, guys, listen. How would I set up the proportion for y?
Oh, that's why. I thought it was a 4.
That's a y, sorry.
Oh.
Here, I'll make it a cursive y. So, here you go.
Wow.
So now, y. So it's 4/3.
Yeah.
What's the other proportion? Well, y is up top, right?
24.
24.
Ask Johan, Jake.
Well, your run is so
3y equals what? 4 times 24 is?
96. Around
96.
6.
Divide by 3.
32. I didn't use the
You
calculator
use
for
the
that one.
calculator for that one.
Wow, you're not crunching.
Is everybody following this? Do you get how we're doing these?
Yeah.
So what you're doing is, all you're doing is, it's all the math you're going to do this week, in this chapter, primarily 90% of the math you're going to do is do this. So if you do this wrong, if you get this wrong, you're going to get all the problems wrong. If you can get this right, you're going to get all the problems right.
I like it.
Okay? So you do need a calc. You will need. I know. I always say don't use a calculator if you can. I always will tell you that. But I understand, for your sake, use a calculator. Get them right. Get it done right. Okay. Okay. So when I do math and I want to make sure I don't make a mistake, I use calculator, because sometimes my brain doesn't function like it's supposed to. Okay. I don't normally.
Don't crunch.
But if I'm buying something if I'm spending thousands of dollars on something, I'm gonna check it with a calculator.
That's good. That's
Okay.
a good idea.
Because,
Tax.
huh? Yeah, stop the video. All right, so here's